Are we recording the show? All right. There's no seats. Wait, there's some seats in the middle. Alright, take a couple minutes so you can figure that out. This one. We wouldn't give you numbers this hard to do on the test. That's not me. I don't think we give you numbers this hard to do on the test. But just in case, you should be able to set it up. That was it. There you go. Alright. There were two of these, and they were both. So now we have one, and it works. All right. For now, at least we have a exponent to pass the last time. We wouldn't actually give you numbers this difficult to work out, but the numbers we give you, we're going to expect you to be able to do. So first, you want to approximate the area from 2 to 10. So 5x cubed plus 1 is just one of these sort of upward tilting polynomial thingies. Okay, and you go from 2 to 10. I recommend you draw a picture because you might get a point for that. You never know. Let's put it this way. If you draw a picture and you can see where you went wrong, that's better than if you just sort of write stuff down. Okay? The idea of partial credit is that we can see where you made your mistake. If you think your mistake's not a big one, you get most of the credit. Okay? If we can't see what you did and you just scribble stuff, you don't get partial credit for scribbling. So the right-hand rectangles would look like this. So they're going to overestimate. And let's find the area of each of those. Well, each of them is 2 wide. And then you would do f of 4 plus f of 6 plus f of 8 plus f of 10. Okay. What is f of 4? It's 5 times 4 cubed plus 1. Then 5 times 6 cubed plus 1. 5 times 8 cubed plus 1. And 5 times 10 cubed plus 1. That is 2 times 321 plus 1081 plus 2561 plus 5001. Is that correct? Alright, so now I have to add them up. Let's see, 1402, 3963, 8964 times 2. Right? Which is 17,890, nope, 17,928. Alright? Okay. Good, huh? Yeah. Alright, so, just to show I can execute. You want to get that again? Ready? Now, how would we write the actual Riemann sum? He didn't get a chance to do that a lot in the Super Bowl, did he? No. I don't think so. Alright, I'm going to erase this. Why? Oh, you want to snap it? Ready? going to do the Riemann sum. So, when you do the Riemann sum, you need two things. You need the width of each of these, right? And then you're going to need the f of these. So the width, well, it's going from 2 to 10. So 10 minus 2 is 8. So this is 8 over n. Okay? And then we have to do f. So you take the starting point, which is 2, and then you add 8 over n times I. Okay, that's the Riemann sum. That's all that's involved. And then you're going to take that and you're plugging the equation. So it's going to be 8 over n, sigma I equals 1 to n, of 2 plus 8i over n cubed plus 1 and 5. Okay? That's the Riemann sum. Yes? You always start at 1. I always goes from 1 to n. Okay? This is always the left endpoint. This is width times I. And so this is the same as this. Okay? Yes? Well, I get points off if you take the 8 out. Well, if I leave the 8 over n inside the sigma, that's fine. You can put it either way. Okay? Because since there's no I in the term, you can take it out of the sigma, you can put it into the sigma. Okay? Now, if you wanted to compute the Riemann sum, you can either do it the hard way or the easy way. I recommend the easy way. Okay, so you would find the integral from 2 to 10, 5x cubed plus 1 dx. So what is the integral of 5x cubed plus 1 dx? Well, let's see, we integrate, we get 5x to the 4th over 4 plus x, from 2 to 10, plug in 10, plug in 2, and subtract. So let's see, that's 12,510 minus 22. Okay, which is 12,488. So far so good? It's not worth it. Sorry, I'll wait till there's a better one. We like that? Of course, as I said, you can work it out longhand, but I can't imagine any of you actually want to do that to yourselves. So there you go. All right. We all understand the Riemann sum stuff? Yes? No? Yes? Why are we doing the 2 comes from? The 2 is the left endpoint. You're starting from x equals 2. Now, right, you are. You're taking 2, and first you're moving 8 over n to the right of it. Okay, so that's why you start at 2 plus 8 over n. Because I equals 1. If I was 0, you'd be doing the left endpoints. You do not have to if you don't want to. Correct. Yes. Why is it 8 over n? Well, how far is it from 2 to 10 is 8, and you're going to cut it into n rectangles. So the width of each rectangle is 8 over n. Now, why is the 8 over n on the outside rather than the inside? It doesn't matter. It could be either place. Okay? You can move it out of the sigma or put it in the sigma. Question? Do you need to write the limit? I don't think you need to. But if you want to, just in case, write limit n goes to infinity. Okay? The important thing is the sigma, not the limit thing. I don't know what you mean. Okay? Other questions? I could do another one of these if you want, but they're time consuming. Let's do some other stuff. We can always come back. All right, you can do some stuff from the review sheet, or I can make up stuff similar to the review sheet. New stuff? Okay. Sorry about the minus signs, That's why I don't punish you guys, but you occasionally miss a minus sign. I was doing this late at night, sit in the armchair, kind of mellow. So maybe you should work out some of these. And instead of falling asleep, I decided to do them. This is the result. Let's see. You know what?
Can you read B out loud?
Sure. B says f of x equals e to the x plus 4 over x, and x at 1 equals 0. That should say f at 1 equals 0. Sorry about that. So that says e to the x. Okay? E to the x plus 4 over x, x at 1, f at 1 equals 0. We'll give you one more. Alright, let's look at it. Find the chalk. Easy problem. F prime of x is x squared minus radical x plus 4. So if we want to find f of x, we integrate that. The integral of x squared minus radical x plus 4
E to the 1 is 2.
dx is x cubed over 3.
2 point something.
What is the square root of x? Well, that's x to the half, so this becomes x to the 3 halves over 3 halves plus 4x plus a constant. And dividing by 3 halves is like multiplying by 2/3. So it's x cubed over 3 minus 2, x is 3 halves over 3 plus 4x plus c. Okay? That's f of x. Okay? Again, so you're just integrating. And then we know that f of 1 equals 8. So who knows what that comes out? 8 is 1/3 minus 2/3 plus 4 plus c. So let's see. That is 11/3 and 8 take it away. 13/3 equals c. Right? So f of x is x cubed over 3 minus 2x at 3 halves over 3 plus 4x plus 13/3. So far, so good?
Yeah.
Do you like that one?
Yeah.
All right. How about the second one? So we're going to integrate e to the x plus 4 over x dx. The integral of that is e to the x plus 4 ln to the absolute value of x plus c. And we know that f of 1 is 0. That's f of x, right? So 0 is e to the 1 plus 4 log 0, log of 1. Log of 1 is 0. So c is negative e. So this would be e to the x plus 4 log x minus e. Did I do that wrong? E to the 1 is e, right? E to the 1 is e, because anything to the 1 is itself, right? Pi to the 1 is pi. Good. Very good. We like to put that stuff in there. You put in pi, immediately 20% more kids get the question wrong. Alright. Now we've got sine x plus 2 cosine x. So sine x plus 2 cosine x dx. So f of x would be integral of sine is minus cosine integral cosine of sine plus c, and f of 0 is 1. So 1 equals, the cosine of 0 is 1, so this is negative 1 plus 0 plus c, so c is 2. On the exam, don't just write what c is, then rewrite the answer. Okay? So here you would have f of x is minus cosine x plus 2 sine x plus 2. Don't forget that last step, okay? Here you'd have to write out e to the x plus 4 log x minus e, and so on, okay? Questions? So far, so good. Alright? Let's give you some more stuff. Let me know when I can erase. It's good? How about? And let's pick up one more. There you go, there's 3. Let's do the first one. So the integral of x cubed square root of 5 plus x to the 4th dx. You look for a function and its derivative. Well, the derivative of x to the 4th is 4x cubed. You had an x cubed. That's pretty close. So let's let u equal 5 plus x to the 4th. Then du is 4x cubed. So I look in the integrand. I don't see 4x cubed. I see x cubed. So I divide both sides by 4, and you get 1/4 of du is x cubed dx. So now I can rewrite that integral as 1/4 integral of square root of u du. Now square root is to the half power, so the integral of that is 1/4 u to the 3/2 over 3/2 plus a constant. Flip the fraction, and you get 1/6 u to the 3/2 is 1/6 of 5 plus x to the 4th to the 3/2 plus c. How are you doing that one? That one is okay? Not too bad?
Yeah.
Difficult, medium, happy? Happy. Alright. Let's do another one. You go from 0 to pi over 2 x cosine x squared. Yeah. Two ways you can do when you have limits of integration. One is, after you do the substitution, you can change the limits as well. Then you don't have to substitute back. Or you can sort of ignore the limits. When you're done with the integration, you substitute back and then you put the limits back in. So for now, that's the only way I've taught it, so we'll do that way for the moment. I look and I see x squared and x, so I'm going to let u equal x squared. The du would be 2x dx. So 1/2 du is x dx. So ignoring the integral, the limits, I would just have 1/2 cosine of u du, which is 1/2 sine of u, which is 1/2 sine of x squared. Now you go from 0 to pi over 2. Okay? That equals 1/2 sine of pi squared over 4, which I have no idea what that is, minus 1/2 sine of 0, which is 0. Okay? So far, so good? How are you doing the second one?
Good.
Good? Alright, my goal is to send some of you to med school. I make a mistake in there? Yes. Say it again. No, it's not the sine that's squared, it's the x that's squared. So the pi over 2 is squared. Okay? Not the sine that's squared, the pi over 2 is squared. You got that? Chris?
I know this from a while back, but are we expected to know the sine of 0, sine of pi over 2?
You're supposed to know the unit circle.
Alright.
Yeah. You got a little more than 24 hours to rememorize it. It's up on the Insta. Okay? You can find it. I put it up there about a week ago. Got a lot of likes for that. I mean, who puts a unit circle on their Instagram and gets likes? Seriously.
Yeah.
Alright, let's do this one. I could let u equal e to the x plus 5. Why would I let u equal the denominator? Well, if I let u equal the numerator, du is going to end up down here. I'd have like 5 plus du. I have no idea what to do with it. So if I let u equal e to the x plus 5, then du is e to the x dx, and this just becomes du over u. The integral of du over u is just the natural log of the absolute value of u plus a constant. So this would be the natural log of e to the x plus 5 plus c. You don't actually need the absolute value of ours because e to the x plus 5 is always positive. Okay, e to the x is always positive. It's never 0, it's never negative. Alright, I had a request for a specific problem. This one I was kind of proud of. This was slightly nasty, but that's okay.
I mean, the sine of pi over 2 is like 1.
I have f is integral. This is number 2c on the review sheet. Cosine x, sine x, square root of 1 minus t squared, dt. So we have to find f prime of 3 and f prime of pi over 4. But first, let's just find f prime of x. So this again, this is on the review sheet number 2c. Okay, so the derivative of this, you're going to get the square root of 1 minus sine squared x. You plug in the top function, times the derivative of sine x, which is cosine x, minus the bottom, which is 1 minus cosine squared x, times the derivative of cosine, which is negative sine x. So then you look at this and you panic because you say, what am I going to do? I don't know how to find the sine of 3. But remember, whenever you do trigonometry, you learned all those trig identities for a reason. Trig identities make your life much, much happier. So 1 minus sine squared is cosine squared. And 1 minus cosine squared is sine squared. And what's the square root of cosine squared? Cosine. And cosine times cosine is cosine squared. Square root of sine squared is sine. Sine times sine is sine squared. This becomes plus sine squared equals 1. So it doesn't matter what number you plug in, you're going to get 1 no matter what you do. Isn't that annoying? I mean, you hate a problem like that. Remember I told you when in doubt put 0. You could also put 1. What the heck? Just look at this and write, it's obvious, it's 1. Just move on. And make a little contempt face on the test. How dare you insult me with such a simple problem? Even a fool can see that this is 1. Alright, let's try something else. You guys were able to do everything in the review sheet with my explanations and all that? That's pretty good. Let's try something then. How about that integral? This chalk is sort of skipping on the board. Sine of the cube root of x will be the cube root of x squared. dx. Don't be intimidated. It's not that hard. You can do it. How do you do with this one? You hate this one? It's not hard. Come on, folks. Actually, it is hard. Take it back. That's alright. You can do it. The cube root of x squared, come on. That's got to be somehow related to the cube root of x, right? So, if u is the cube root of x, also known as x to the 1/3, then du would be 1/3 x to the minus 2/3, which is the same thing as 1/3 times the cube root of x squared. Gotta have a little faith. Okay, you gotta figure this. Otherwise, how will you integrate this? So 3 du, oh, this is dx, would equal dx over cube root of x squared. So this would be 3 sine u du. And the integral of sine u is negative cosine u. This is negative 3 cosine u plus a constant, negative 3 cosine of x cubed plus c. So far so good? Why is the dx in the numerator? Here? Put the dx in the ones, okay? Don't be afraid, ask questions.
That's all.
Oh yeah, come on guys, you know that. I need you guys to proofread my books. It'd be very helpful. 4? Alright, let's give you another question. Okay, so G of x.
Question.
Okay? Here's 3 fun questions. Yes?
What's the bottom axis like? What? How deep does it
Oh,
go?
that's minus 4. How's that?
Yeah, I'm doing that for
How long have you guys? See, in the video, we're going to cut all of this space out. I don't know if any of you are watching the videos. Are you watching this at home? Then they're going to close caption these so that you don't have to hear me. You can just read. Yes.
So is the radius 4 or 2 for the semicircle?
What do you think?
Well, I mean, if you go
Oh,
plus 4,
that's a good question. Come on. You know what I meant? It's hard to make this stuff up on the spot. It's got to be 2, right? Otherwise, it's not a semicircle.
You just choose the thing.
Did that change your answers? You want to make it 4?
It doesn't choose the
No, it screws up the other part.
Yeah.
All right. So, g of 0. Well, the integral from 0 to 0 is just 0, right? Because you're not going anywhere. Anytime these two numbers are the same, you get 0. Because you haven't integrated anything. Right? You started and finished in the same spot. Whatever you get at the top and whatever you get at the bottom, when you subtract, you get the same answer. Alright, we're going from 0 to 8. That's what g of 8 is. From 0, 8 of f of t dt. The t is a dummy variable. It doesn't really matter what it is. Well, that would be the area of the semicircle, which would be pi times 2 squared over 2. Feel free to plug in 4. Okay? Minus the area of this triangle. Well, that has a base of 4 and a height of 4. So that's got an area of 8. So that would be the answer. So it would be 2 pi minus 8. For those who use 4, it would be 8 pi minus 8. Okay? Now, where is g of x a maximum? Well, you could do it 2 ways. One is you could do it intuitively, by just looking at the areas. The other thing is say, well, look, I get some area here, right? Then I subtract a bunch of stuff, and then I add some stuff back. So the question is, have I added back more here than I subtracted here? No. So I had to be bigger here. Okay? Does that make sense? I had to be at my maximum area here, because then I subtracted 8, and I only added back 2. The other is you can take the derivative. Because g is a maximum, well, we're going to want to find where is g prime equal to 0. Well, what is g prime? G prime of x is f of x. Right? If g of x is the integral from 0 to x of f of t, then g prime of x is just f of x. So f of x is 0 in 2 places. Here. Here. And here it goes from plus to minus. It's going from up to down, so that's going to be maximum. Here it goes from minus to plus, so it has a maximum at x equals 4, and it'd be a minimum, if we cared, at x equals 8. Okay? If I ask about concavity, you take the derivative again. Did I skip g? Oh, I forgot g prime of 4. Well, sure. What's g prime of x? G prime of x is f of x. So g prime of 4 is 0. Remember I said, when in doubt, what do you guess? There you go. It's not really a great strategy. Right? It's like on baseball trivia, when in doubt, you guess Satchel Paige. How do I get g of 8? Sure. It's the integral from 0 to 8, so it's going to be the area of the semicircle, right, which is 1/2 of pi r squared, so it'll be 2 pi, minus the area of this triangle. The area of that triangle is 1/2 base times height is 8, so it'll be this minus 8. Okay? That's good? Questions? All right. Everybody study hard. See you tomorrow night at Javits at 8:40.